This is stage 5 of the force strategy for pushing your exam grade up to an A or A star in Physics A level. So stage 5 is E for exam strategy. So this is all to do with communication and clarity. So there are some similarities here with some of the points we've mentioned already, but that just means they're really important. So let's have a look. Typical marks lost. So we've got 6 to 12 marks on average per paper. So this would be misreading questions, not understanding or ignoring the command words. We will clarify those later on. Not showing the working. We've mentioned this a few times. This is so important. You've really got to show your working. Absolutely important. Running out of time, we'll talk about how to manage that. And missing the clues in the question. More about that later. So typical examiner comments. So many candidates did not answer the question asked. That is so important. We'll talk about how to avoid that problem. And then responses lacked structure and precise scientific terminology. And there's lots more similar comments we could have a look at if we wanted to. So what are the key points and the key strategies for stage 5? Let's have a look at these one by one. The first one is the cliche, read the question. Now your teachers will have told you this for years. It sounds a little bit patronizing, but it's so important. And I know I'm guilty of not doing this myself. If I'm rushing, if I'm trying to answer a question for a lesson, I might skip through the question and I think, oh yeah, I know what this is. And I'm off on a tangent and I'm not necessarily answering the question that's been asked. So that is so important. You've really got to take your time, take a deep breath, identify which topic it is. That's so important. So if there's anything to do with waves, it's probably a waves question. If they've mentioned energy, what do we know about energy? So try to identify which topic in the Physics A level course and which skill the question is referring to. And that's so important. So we're confident before we start the question. We could also, and this requires a lot of discipline, after you've answered the question, is go back and read the question again. And that takes a lot of discipline to do, but very often you think, oh crikey, I haven't actually answered the question. I've gone off on a tangent or I've added some extra detail which wasn't required. The command words, so these are really, really important. So if you look at the workbook later on, it identifies what these are. So in your specification, these will be listed. So identify what the question is asking specifically. Is it asking to state something, or define, or explain, or discuss, or calculate, compare, sketch, evaluate, and so on? So there's these are fairly standard command words, but you might get a list of these from your specification. So you need to be really, really clear what the question is asking. So it's fairly similar to the first one, but specifically, if it says state, then that is just a 1 or 2 mark recall along with define. If it has to calculate, that's pretty straightforward. If it says explain, very often the question will say define and explain, or state and explain, or describe and explain. So the explain is going to be the higher marks, the discuss, the compare, the evaluate, those are going to be the higher marks. So that should link in with the 3, 4, or 5 marks allocated to the question. Show every step in your working. We've mentioned this at least once before in the earlier videos. This is so important because you can get the final answer incorrect. If it's a 3 mark question, you can still get 1 or 2 marks. And if you do this all the way through the paper, you're picking up every single mark you can possibly get. So what we mean by show every step is write the formula, rearrange it, substitute the values, and then write the answer with the units. If you're doing that in a very disciplined way, even if you make a maths error or you forget to divide the diameter by 2 to get the radius, whatever else it might be, you get the wrong answer, but you get marks for your working. Very, very important. Correct physics words and terminology. So there's loads of examples I could give here. These are just some which come up regularly and annoy me as a teacher, and they will annoy the examiner as well. If you're talking about braking, for example, a braking distance, a car slowing down, you have to spell it correctly. And a student said to me recently, well, we're not being marked on spelling. Well, not necessarily, but if you spell the word incorrectly, it means something else. So braking distance is not the same as breaking a cup on the floor. It means something different. So you have to spell the words correctly, even if it's just a normal descriptive word. Another very typical one is students love writing the rate of acceleration. It's not the rate of acceleration, it's the acceleration. The rate of acceleration is how the acceleration is changing with time, which is something more complicated, and we don't need to necessarily know about that. But it's the acceleration, not the rate of acceleration. So you have to use the correct terms and use them correctly. Another one, and we'll mention this later, students very often talk about gravity is acting downwards. Well, no, it's not. The weight is acting downwards. Weight is the force of gravity, or the force due to gravity. So you have to use the correct terminology throughout. You have to spell it correctly, otherwise you will lose easy marks. Manage your time. So you will have been told this for years throughout GCSE as well. On average, it's going to vary a little bit, but look for about 1 minute per mark. So if it's a 1 mark question, you should aim to spend about 1 minute on it. If it's a 6 mark question, 5, 6, 7 minutes approximately. You need to be really, really disciplined, and very often students run out of time because they've spent 20 minutes on a 5 mark question and then they don't get to finish the paper. Now, there are various strategies for this if you feel like you want to take it to the next level. Some students will look at the entire paper to start with and start on either the easy questions or the low mark questions or the questions they feel confident with. You don't have to work through the question paper in terms of number order, 1, 2, 3, 4, 5. You can move around in any order you want. So yeah, but you do need to manage your time. That's so important. The last one I'm going to mention is look for the clues. So this could be, very often part A will be show that the value of G is 9.8, or show that the weight is 15 newtons, and so on. Now, not always, but the majority of the time, a show that question is saying that here's a value that you will need later on in the question. So if you get to part B or C and you think, I don't know how to answer this, well, why did they tell you to show that X is equal to 10 or whatever it might be? Because you need that value 99% of the time. And related to that, if you get to part B or C in a question and you think, I have no idea how to do this, well, why did they ask you to calculate whatever it was in part A or B? So that's the same idea as the show that. So look at earlier parts in the question for clues. Why did I calculate something to do with energy or something to do with the time, whatever it might be, because you probably need that later on. The other really important thing is, I think especially for complex, applied, synoptic questions, is very often students think, well, I haven't studied this. It wasn't in the textbook. We weren't taught something in lessons. However, the paper is trying to assess your understanding of the course. So they don't want to know what you think about something that they've put in this contrived scenario. They want to know, do you understand the course material? So you need to find a link between the question and what you've studied. So it goes back to this idea of the first one, understand the topic and the skill the question is asking. And this little summary here I think is very important, because you can know a lot of physics, but if you don't put it down clearly in a structured and order and timely way, which is good exam technique, then you will not get a good grade. The exam question that I've picked it's a longer response question. However, it does lend itself to illustrate some of these ideas that we're talking about. So you might want to pause the video at this point and attempt the question, give yourself 10 minutes, and then we'll have a look at a typical answer, or a kind of grade C, grade D answer. So here we go. So we've got, this is my attempt at the drawing. This is a version of an exam question from a few years ago. So there's a man, this is a man, on a ladder, it's resting on a wall. So we've got to label the other three forces. Okay, use the principle of moments to explain why this is stable, but will topple over if theta becomes too large. So you can imagine that if this ladder here becomes more vertical, at some point it will fall backwards. So let's have a look at the answer. Right, so this is one we mentioned before. So very often students will say gravity. You won't get a mark. Now, you may have a sympathetic examiner or maybe a generous mark scheme, but gravity is not a force. Gravity is a field. So the weight due to gravity, or the force due to gravity, would be the weight. So they wouldn't probably get a mark for that. Now the normal force, the normal reaction force, you would probably get that. Obviously you would need to label these correctly. These are the two reaction forces. Probably better to say, as we'll see, to specify it's the normal force of the wall on the ladder or the floor on the ladder, but that would probably get 1 mark for those there. The ladder is balanced. Okay, this is part B, which means the moments are balanced. Okay, yes, they might get a mark for that, but they haven't specified which moments. All the forces are equal. This is a really typical statement that my students say, well, they're not necessarily all the same. Maybe we could write the resultant force in any direction equals 0. That might be correct, or the sum of the forces up is equal to the sum of the forces down. But to say that all the forces are equal is almost certainly not true. If theta is too big, the ladder will topple because the forces will not be balanced. Okay. They might get overall for part B 1 mark, possibly 2, but probably 1 mark. They haven't mentioned or stated the principle of moments. So this is a big clue here. It's all about moments. They haven't defined the frame of reference where the pivot is. They haven't talked about which moments, or indeed what will happen specifically if theta becomes too large. So not enough structure. They haven't used the terminology correctly. It's not clear. They haven't used the clues in the question. So let's have a look at a better answer. So this will be the model answer. So let's go through this stage by stage. Part A, the weight, absolutely, that's fine. The normal force, so as we've said, of the wall on the ladder, of the floor on the ladder, that will be better detail. You probably don't need this. So there's 1 mark for both of these together, but it's good to get that actual detail. Right, so let's have a look. So why is stable? So it's stable because we could say the forces are in equilibrium. We could say the moments are in equilibrium. We could, at this stage, write what we mean by the principal moments. The sum of the clockwise moments about a point is equal to the sum of the anti-clockwise moments, and that would get a mark. But we need to define where the pivot is. So the pivot is this point here. We're going to take moments about the bottom of the ladder. So if you've mentioned that the pivot is at the bottom, at any point that would get the 2nd mark. So we need to say, or we could say that these 2 forces here, so the frictional force and the normal force at the bottom, they're going through the pivot. So by defining where or identifying the pivot, we could then say that these 2 forces, because they go through the pivot, will have a moment of 0. So we only actually have 2 forces we need to consider. We've got the normal force here and we've got the weight. So the clues in the question are identifying the forces. So why have they asked us to identify these forces? Because we need to make reference to them in part B. So when in equilibrium, the clockwise moment, if we just say clockwise moment equals anti-clockwise moment, that probably isn't going to get us a 2nd mark. But if we identify it's this force here, to the clockwise moment, which force of the normal contact force, this is trying to make the system turn clockwise, is equal to the moment, we could say anti-clockwise, of the weight acting about the pivot. So we've applied the principle of moments to this situation. So we've got 3 marks there just by saying principle of moments, what's causing the moments, and where the pivot is. So that shouldn't be too difficult. So what's going to happen with theta? If theta is large enough, the center of gravity, this weight, is now going to move to the right-hand side. So there might be this midpoint where they're just balanced in a comical way in a vertical position, but that probably won't work anyway, because as soon as the ladder's vertical, then the weight of the system is going to be to the right anyway. So the moment of the weight is now clockwise, so that's changed. Originally the moment was anti-clockwise. Now with theta much larger, the moment is now clockwise. So then you could either say the sum of the clockwise moments is greater than the sum of the anti-clockwise moments, or you could say nothing is providing an anti-clockwise moment to balance out this clockwise moment of the weight. Therefore, the ladder will topple. So we've talked through, this is your 3 marks here, what will happen in terms of the forces and in terms of the moments if theta becomes too large. So going back to our strategy mentioned before, we've got the correct terminology, we've read the question, we've identified the clues, we've applied the physics that we've learnt. So there's nothing on the course about ladders and people climbing ladders necessarily, but we've basically written out all the stuff that we've learnt on the course about moments and pivots, and clockwise moments and balanced forces. Okay, well done. So this is the end of the force strategy. Hopefully you found the workbook for each of these 5 stages. And certainly now you should have a look at the final part of the workbook, which is on stage 5. I hope you found this useful and go for that high grade. Best of luck.